All right, everybody, please try to find a seat. We're going to get started here with our last panel of the day before we head into the reception later on. So I'd like to introduce our esteemed panel of experts here on the network orchestration panel. Representing the networks of ESnet, Internet 2, and NORDUnet. We have, in the correct order, from my left, we have Marc, Johannes, Karl, and Markus. And they are going to be going over a little brief presentation first, and then we would like this to be as interactive as possible. So we will be throwing out a lot of questions to the audience and hoping that people can interplay with some of this topic. So with that, I will turn it over to whomever was going to start with the slides.
Yep, that will be me. So thank you so much, Jason, for the introduction. So yeah, my name is Marc Koerner. I work for ESnet for a little bit over 3 years now. I joined during the ESnet 6 project. I'm part of the software engineering group in a subgroup which is responsible for orchestration and core data. And so I'll jump straight in. So this is basically our network. Some of you might be already familiar with the slide. It's also on our website. So ESnet's main mission is to interconnect all the national laboratories. We also connect some NNSA sites and some other DOE facilities. We have equipment in 380 locations, mostly across the continental US, as well as in some of the some satellite sites in Europe. This is also where one of our biggest upstreams is coming in. That's basically from the experiments they do at CERN, at the LHC. And we have our network is composed out of approximately 350 core links. Between routers, we have 300 customer-facing interfaces, and almost half of them are operated with 100G. And yeah, so that's a little overview about that. And then I'll come straight to our orchestration platform. So this is basically what we call the OCD stack. It's composed out of 3 main components. It's ESDB, which is our equipment database, where all the planning information goes in. Then we have the workflow orchestrator, which is an open source tool. So this tool we use to apply intent. And then finally, on the bottom, directly talking to the network, we use the Cisco Network Service Orchestrator. So we have built a bunch of services for the orchestrator, which kind of directly translate into configuration information on the routers. The good thing here is NSO has the notion of services, which means we are configuring 1, 2, or n devices at the same time, depending on what kind of service we deploy. And yeah, so there's actually there's even YouTube clips on the internet how the system is working. So if you want to look for that, I can help you with it. But yeah, I'll leave it with that for now and hand it over to Karl.
All right, I'm Karl Newell, network software architect at Internet 2, and Marc had a map, so here's our map. So we run the nationwide network to connect research and education, similar to ESnet. You know that Scenic is one of our major partners. We recently overhauled our network a couple of years ago, and as part of that, replacing our gear, we decided to fully automate our network, and that's the path we went down, and we'll cover some of that in the Q&A. Oops, wrong thing. And here's the similar block diagram that I have. I had Marc do his slides first, and then I could just copy them. But what's interesting is you see there's a lot of similarities here. I mean, we kind of all, we worked on this. Well, actually, ESnet and Internet 2 were sort of doing the same work in parallel. we talked a little bit about it, but we ended up with similar design solutions independently. Like ESnet, we have NSO as our orchestrator that's pushing out network config. But then we have some other tools that that we're using in our network. Like we use NORDUnet from Network to Code, which is it used to be a NetBox fork. That's sort of our database. We have tools. We have a tool called the Reconciler that is responsible for pushing or syncing up data between NORDUnet and NSO. And we've written another set of tools called the Insight Console and the API on top of that. So we have a full web portal for people to provision L2 and L3 VPN circuits on our network, primarily for Cloud Connect. But as we evolve that, we're going to be adding more and more features, and eventually all of the Internet 2 member services will be available in the console and via an API for members to provision.
Hi, I'm Johannes Houen with NORDUnet. For those not familiar with NORDUnet, we are sort of a Scandinavian equivalent to ESnet 2 in that we're not an NREN, but we sort of the glue that connects a lot of the other Scandinavian NRENs, as you can see in this slightly outdated map. NORDUnet, the Norwegian NREN, has since changed name to SIGT. But yeah, we operate a lot of services and infrastructure used by the Nordic NRENs is the short version of it. And here's our automation setup. We're sort of the odd one out here in that we have for a long time run a NSO-based automation setup, but we're transitioning into a more or less homebrew open source thing called ClickSon. I'm sure we'll get into that more later, but in short, it's we find ourselves needing to transition away from NSO. And one of our partners, the Swedish NREN ESnet, decided to go ahead and make ClickSon, and we decided to jump on the bandwagon. Our setup is much simpler. We don't have anything you would really call advanced orchestration at the moment. Maybe sometime in the future. We do have an IPAM setup. We integrate with NSO and a homebrew network inventory system called NI, as you see in the diagram here. So we've decided to go down a little bit of a different path from the other two entities represented here in the panel, but sure we can find out something interesting about that.
So Marcus, and also from NORDUnet. We're actually going to open it up shortly, or rather right now, for questions. I do have some questions that I can ask them, but they're boring. So if you have any kind of stuff you want to know about what we do with network automation and orchestration, then please do go ahead and find the microphones. But I can start up with one question, which is like, to what extent is your network orchestration networks orchestrated or automated?
Maybe we just go down the line. In some regards, our network is, I'd say, 100% automated. I mean, when we went to replace it, we decided to get it completely covered, at least from a config management perspective. So all of our lines of configuration are fully automated and fully under control of NSO. But that, I know that doesn't mean we're done. There's still a lot of other pieces, that other work we can do. We can pull other pieces in, do more orchestration, which is really, to me, is about taking pieces from disparate systems, aligning them, and then, reconciling them and putting them, through something like NSO into the network. But again, as at least from a config perspective, we do have 100% coverage in all our configuration.
Yeah, I think the most honest thing I can say here is that our automation is sort of need-driven, in that we automate the stuff that's really taking time away from our network engineers and where we really get some bang for our buck. But a lot of stuff still manually configured, along with all the difficulties that comes with that, having to deal with NSO in that regard. This is something we're hoping to change with transitioning to ClickSon, but since that's still in the future, that's only ambitions at this point.
Yeah, I think for us, it's kind of similar. I think most of our layer 2 packet forwarding hardware is in NSO. So all our core and management routers. We also, so these are completely managed and orchestrated with NSO services all the way up into the orchestrator and ESDB. We also manage some of the transponders, which are connected to our optical equipment with that. But so we just started managing configuration on them. So we have the nets. Some of them are we built them in-house. And so, yeah, we just started managing config on them, but we have the devices in NSO for quite some time. The optical, the ROADMs and firewalls are currently not part of that. I don't know if there's any any plans to change that. I don't think so. Yeah. But also for the audience, please jump in whenever you want. We would like to keep that as interactive as possible. So if you have any questions, anything you want to know about a certain setup or something, jump in every time.
I'm Cameron from Scenic, and I was curious about the reconciler that you mentioned, Karl. I guess kind of how that works, and is it more of a running in the background type of thing? And does it ever get into, say, a stuck state where someone has to intervene?
Great question. Actually, so the reconciler is it's all Python code. It was actually modeled sort of after how Kubernetes works, where you essentially have something declaring your state, and the reconciler's job is to get all the pieces into that state. It actually has a custom queue manager that one of our developers wrote. Again, it was to solve some of those edge cases that you can run into where maybe two jobs get submitted to the queue that are the same, and you don't actually, you don't want two of the same job in there. It can actually take care of that. But basically, it sort of reacts in two ways. One is it is constantly watching the Nautobot changelog, and so that just emits anytime something changes. It's constantly polling that. Once it sees a certain kind of change, it doesn't react to anything in the changelog. It just says, "Oh, this specific object changed. Now let me query the Nautobot database, find the object, figure out what it is, and then push those changes down into something like NSO." It's actually, sometimes it goes a little bit both ways. It also runs a timed loop, like every 15 minutes. It pulls all the stuff out of Nautobot and pulls all the stuff out of NSO and figures out the difference between those. We're actually, in that case, we're using a library called diffsync, which is also from Network to Code. And that's kind of what its job is. You kind of build up these object models, and you can feed them from two different data sources, and it can quickly diff those. And then you can run jobs that say, push the diff one direction or the other. Does it get stuck? Probably. It actually hasn't been, it's only been in production for a couple of months. As far as I know, we haven't seen any issues with it getting stuck, but that certainly could happen.
Do you push diffs in each direction? Do you sync from devices as well as to, or? So?
Yes, don't do that. No, it's always really hard to, I guess it's complicated. So NSO knows all the devices on the network and knows all the interfaces. So we actually pull that data through NSO using the reconciler and put that in a Nautobot. Then our services like L3 VPNs and L2 VPNs, those get provisioned via the API or the console into Nautobot, and then the reconciler syncs them that way. There's almost no piece of data that gets synced bidirectionally. Because you run into that problem is which one is the source of truth? Which one's canonical? You could just battle that all the time. So we try to avoid that at all costs. So yeah, actually, I don't think there is anything we're syncing that we're syncing bidirectionally.
So what you're saying is the Nautobot is the source of truth in this case. That's the one that's sitting on the data at Newell. Yeah.
Yep. Yeah. Nautobot is our source of truth in our database for storing. Right now, just the stuff that's part of the Insight console in our virtual networks. We have another database that we still maintain that we've traditionally used on our network. we might eventually move all that stuff into NORDUbot, but right now NORDUbot drives all of our virtual circuit infrastructure.
Yeah, so I think this is a very common issue, right? Since like once you start using NSO and you manage the configuration on an external system, so configuration can change. So we actually have something similar. So yeah, again, like the problem is that the configuration can change either on NSO or on the network side on the devices, and then you kind of need to figure out, okay, so in which direction do you sync? As far as I know, we do only sync to, so we don't sync from the devices. But so we do have something which like we call nightly validations. And it's kind of like just a batch job who is trying to do a redeploy and just looking at the dry runs. So it's basically something we run in order to figure out like how many changes our network engineers did on the devices without using NSO for the change. And so this is kind of like something we try. So we used to anticipate to break things. Did you guys do something like that at NORDUnet, or like did you take the key to the devices away?
We no, as I mentioned, we are sadly still at a place where far from all the services we use are implemented in NSO and won't be implemented in ClickZone, at least initially. What we're doing is we have access control lists and prefix filters. We do EVPN over as a service in NSO, but a lot of the baseline configuration, a lot of the simpler stuff, a lot of the stuff we don't deploy on a large scale, that's manual, and as such we run into a lot of out of sync problems, and we don't have a very good way of handling it at the moment. It's more a case of running into it as you're doing something and having to handle it at that point, rather than having any way of diagnosing it ahead of time.
Yeah, I guess one of the problems we get from time to time is that somebody's been out and changing something on the devices, and then you do a sync from either in the morning or during the night or whatever, and then your service is out of date, and you try to deploy it anyway, and you'll even with the new sync, you'll try and deploy it, and then somebody has put some device into a southbound lock, and then all hell breaks loose when that device is no longer southbound lock, because then you either have to do a sync to, which we never do, or you have to like again do the southbound lock, then pretend that you delete stuff from the device, and then do a commit, and then roll on your service again, and then say, okay, now please go out and do this to the device, and then it'll go out and look at the device and say, okay, everything is fine. I don't need to do any diff now. So yeah, fixing it behind NSO's back is one of the things we've been doing way too often.
Yeah, I think we have seen that at the very beginning quite a lot, actually. It is getting better. So because the network engineers, they start really liking the tools we built on top. So we had a minor incident where we had to temporarily turn everything down. And it was literally like we got approached like, turn it on again. We have some maintenance to do, and we can't do it anymore without. Well, they can, but it's just so convenient, and it makes the job so much easier. And that was really rewarding to some extent, because in the beginning there was some discussion, and also when we started introducing NSO, it was really more about like to give them like to still have the possibility to have them using a CLI to configure things, but just do it on NSO instead of the devices. But in the meantime, I think they really appreciate all the tools we have built on top and around it, so that they don't even do that anymore. Like it's so convenient. You have your predefined workflows. The data is already in ESTB. You just click a few buttons, apply it. You check the dry run results, and then you confirm it. And if everything is fine, like you're done. Like you are all set. We reduced work of multiple days up to an hour or something, and So I think people really appreciate the orchestration in the meantime. And also the talk you heard yesterday with Oscar. So we like the out of sync issue we saw only a few times now. So it's really getting a lot better. In the beginning, we had that a lot, that it was basically anything breaks when they try to orchestrate something or execute a workflow on the orchestrator. And then 99% of the time it was like, okay, go into NSO, do a sync, and then you'll be fine. And yeah, so again, these incidents are getting less and less, which is actually a great sign. So they use the tooling we built.
So I guess I can post another question. Is so how are you? So for Internet 2 and for ESnet, how are you using NSO? As in, how are you developing your services? Are you using whatever templates, or are you using Java or Python or something else?
Yeah, so I mean, most of our stuff is there's no Java. It's all Python and the NSO templating engine. And I guess I don't know without having to get in a lot of detail for folks not familiar with NSO, but you basically have device templates that are in XML, and they sort of look like device configuration. And you can put variables in there, and those variables are what comes from the NSO service, which is defined in Yang. And then you run that through. You can run that through Python or Java. Ours by default, we always have them run through Python, but sometimes we don't even do any work with Python. We actually made a decision to try to use the, Yang constraints and the templating engine as much as possible, because that's to me, that was the power of NSO. So, why try to do it on my own? There's definitely some downsides to that. There's probably things we could have done a lot better, especially like data validation inside Python. But it's the path we took.
Yeah, I think we basically do the same. So there's so you have mainly the templates where you apply the configuration. And so the first batch of services we wrote, they also still had a significant amount of Python code, mostly for like validation. But so we really started off by introducing that as the main tool for our network engineers. Again, we went through this transitioning period, and they just wanted to have a CLI, and so we were basically making sure that whenever they create services on NSO, that there will fall out some working configuration. So, and when I say validation, it's really like making sure that certain services getting a VLAN out of a specific range, which is allowed, or that values, like again, automation or orchestration is a lot about taking like minor human errors away, like typos or things like that. Which kind of end up being a big deal at the end of the day, like depending on where you have the typo. And yeah, so we do the same. We have Python templates, Python logic, and then just XML templates.
Yeah, in the case of NORDUnet, we don't use templates at all. It's mostly a preference on the part of our network engineers, who, after all, wants to use the tool. We have a lot of legacy Java services, and we were starting to develop services in Python before the decision was made to move to a new system, which is all Python in the case of ClickSon. So now it's 100% Python. ClickSon does support templates. We don't plan on using them, but our partners in the development, ESnet, are using them to a great extent. At least to deploy baseline configuration to devices.
Do you build the model in Python, like the config, I just wonder, like, how does that look like because like with the NSO templates, it's a little bit what Karl said, like, so when I started working on the services, and I was like, I'm really new to it. So the way I created the first services was just like I configured it on the device with NSO, and then I did a dry run on it and did display XML, and then I was kind of like using that as the initial template, and then replaced it with the variables. Like, how does that look like on ClickSon? Is that a similar mechanism, or?
So I haven't actually used the templates in ClickSon yet myself, but it's very similar to how it works in NSO. I think off the top of my head, but so are you asking about the templates in ClickSon or how I do instead of templates in NSO?
Yeah, it's more like I'm trying to understand how you kind of build the configuration template. So there must be some way to, like, how do you,
How do I make the structure?
Yes,
Yes.
basically, how do you push it?
It's sort of a byproduct of the first service I made was the EVPN service in NSO, which had a lot of branching logic. So you would sort of end up with, if I started out with a template, you would end up with a lot of logic having to mutate it to different structures depending on different scenarios. So it's more a case of slowly building it up via the code and having just comments dictating. Now it looks like sort of like this. So it's not really a template or any kind of. It's sort of just comes along as the code goes along. It's quite pretty fluid, you could say.
But also in the case of the Python services, yeah, it's all mappy manipulation of the configuration, right? Again, with some devices like we in NSO we have both Aristas and Junipers, and of course there's different configuration for the different devices, which is just handled by subclassing.
No.
Hi, this is Evangelos from ESnet. My question to you guys is, what kind of steps forwards do you see in regards to the community that is around you here today? What kind of collaboration do you want to see going forward, and feedback from, not just us that we know each other, but the wider area that is around us?
Speak with no.
I mean, Internet 2, from our perspective, we're just trying to, foster a community around automation and collaboration and orchestration and figure out what our members want. We do have like the Internet 2 community. There is a growing group of folks using NSO, and I'm not saying that's the only way to do it. It's just, it's convenient for us because we have experience with that. And so we're now trying to help those organizations understand how they can better leverage NSO. But I also don't want to be specific to, one product, especially, a product that, folks have to pay for. So I think it's just around efforts in, sharing our experiences. How do we get started with automation? How do we convince? There's actually two things. You got to convince two groups of people. You got to convince your managers and directors that this is something you need to spend time on. You also have to convince your engineers that this is something that they'll benefit from. People are very, some people can be very worried about this. Oh, you're going to automate me out of a job. No, we're not. There's plenty of work for you to do. You should not be making VLAN changes. That should be fully automated. And, managing up, it's about, we can free up our engineers to do, to do other kinds of work and do more engineering. We can actually reduce mistakes in the network, which is going to reduce downtime. And so it's really about how do we work as a community to, foster this adoption of automation.
Yeah, for us in NORDUnet with ClickSon, it's we're very open to helping people with it. It's a very new thing, ClickSon, to be used in this way. Having only been developed for this for a couple of years now, and only deployed by ESnet so far. But it is open source and it is free, which is a significant difference. Though it is not, you couldn't call it mature quite yet, maybe. So.
For us, I think there's a German saying, do something good and talk about it. So I think we really try to engage with the community and kind of like it's something which is just in our mission, and we're always trying to kind of get more into open source. So the thing is like the workflow orchestrator is probably the product where we do the most community interaction and engagement at the moment, because more and more NRENs start using it. With NSO, not so much. NSO was a no-brainer for us. It's just like it's a very mature product, to use the same word as and so we have full support on it, and it's really we get a lot out of it, and it's working pretty well for us so far. We are open to alternatives, but so yeah, that kind of like brings me to my next question. How is the ClickZone journey going so far for you guys?
Well, so far, ESnet has deployed, I think, 70 devices running on ClickZone, with something like 6 services running on top with multiple instances. I don't know how many instances of services. They've run into some hiccups with like it does use quite a fair bit of RAM, and it also gets some timeout from time to time when you try to push to 70 devices at a time. So yeah.
Harvey?
So when I came into this session and I saw network automation and orchestration, also the sites are doing orchestration and automation, as was already mentioned, for example, using Kubernetes. But the operations and the goals are quite different. And so the question is, how do you bring these two different systems together? So far, the network can behave with enough capacity as an open system and a kind of utility. But knowing what we know about the capability of end systems, which well, fortunately or unfortunately, the end sites don't know well how to use them. But as soon as they're taught, they will see the limits of the infrastructure. And then the interaction will become much more interesting and stateful. And so then I really wonder how the sites and the networks, the wide area networks and the regional networks can work together in a consistent way, because they each have their own perspective and goals on this subject of network automation and orchestration. So how do you see that? This is going to be quite a change, right? Are you prepared for it, or what's your perspective?
For bare minimum is provide programmable access to our network, which is, I think, all of us do to some extent, and through the problem is that there's various ways of doing that, but in our diagram, that at least for our virtual networks, which is layer 2 and layer 3 circuits, it is fully API driven, so that can be leveraged. And then it's really around coordination and communication with those other partners, like working with Fabric, and that Fabric is they are integrating with our API so that the folks that are using Fabric will be able to leverage the circuits on our network. And again, then it's just education around there are we can provide a programmable network that'll meet your research needs.
Our use case is much simpler. We have one what do you call it? VM hosting service, which we need to provide access for via appropriate VLANs, and then we're pretty much running in terms of NORDUnet. ESnet's system I don't have in my head currently. Maybe Markus knows more there, but other than that, we mostly need to worry about peering and general traffic rather than compute or data storage or anything like that.
Yeah, I agree. It's a very interesting question, so yeah, I think this goes really back to where Vangelis is one of the main developers with Oscars, and something you, Harvey, are probably familiar with, that we use Oscars as a kind of like lower hierarchical component for the Sense orchestrator. which kind of allows scientists to kind of exclusively like book bandwidth across our network and other networks. So I think this is kind of like a term, and we even internally use more and more. It's kind of like the self-service. And this is even something we as software developers were asking for. That I said, like, we had discussions with our infrastructure guys that we said, like, okay, look, like we need more. Like, so when I need a VM today, I kind of need to write a ticket or something and submit that request, and then someone reaches out and asks me, okay, how exactly do you want that spec'd out, or what access do you need? And I think there's really a self-service is really a main driving force there, and so we are not quite there yet, but I think that one of the visions is that we open up more and more to self-service to our end customers, so that they can on demand book certain services, like similar to what Oscars already does today, but like more from a wider portfolio when it comes to end connectivity or something like that. But yeah, again, we are not quite there yet. But so once this all matures more and more, so we certainly have the vision to open this more up to our customers, so that they have some sort of a portal. Everything is nicely encapsulated, so nobody can break anything, and that they can basically self-service, like increase their bandwidth or whatever. Like, yeah, I think this is certainly the direction where this is going.
So why don't you simply use Ansible instead?
I was hoping you'd ask that question, because you can't put Ansible and simple in the same sentence. No, and actually, there's actually some people doing some great work with Ansible. I think actually Johannes is gonna, they're using that as the backend, and they're actually working with the workflow orchestrator to use that as well. I mean, for us, so NSO is declarative and it's idempotent, and what's actually really cool about it, when you delete a service, it rips all that config out. It keeps track of everything. The Ansible world, things are getting a lot better, but you got to write a playbook to put config on. You got to write a playbook to take config off. And if you're in the middle of deploying stuff and it all goes wrong, like you probably have to figure that out manually, or you have to write a magic playbook to figure that out for you. Now, I'm not saying this can't be done. It's just that NSO, like they put, like the power of NSO went really into that. It's a declarative language, and it keeps track of everything for you. And it, and it sort of, I don't want to say it self-heals, but if you try to deploy something to multiple nodes with NSO and one fails, it rolls the whole thing back. It treats your whole network as an atomic database. And to me, that the power there, that made sense. I mean, our cost benefit analysis on something like NSO is it's worth, and what we pay for it, as long as it's not more than 1 FTE a year, that is worth it to us, because that's how much we would have to spend on maintaining our own system like that.
Yeah, just mention. Oh yeah, well, perhaps Johannes want to do that instead. But yeah, I'll just mention that. Clixon has the ability to auto delete stuff as well as it is right now. It's quite neat when the main developer came and said, I think I cracked this one and actually have something that works, and it works.
Yes, I think Clixon works in a very similar way in that regard, and just keeping track of what you have deployed as a service. And since you have kept track of it, you can roll it off again. No problem, same functionality. If you ignore scalability, Clixon is very competitive. Yeah. So I think if you did it up in completely cynical dollars and dimes, it was sort of 50-50 whether or not we would go with automation, given the scale of things we work with and the complexity of things we work with. And in we ended up going the route of developing a new tool, which could be used by people who don't have the need for something as complex or expensive as NSO. But given that it's also it's also very complex making a tool like that. It couldn't replace NSO in a large installation. Certainly not yet. Yeah.
Yeah, I'm curious about how you guys test and deploy changes to services. So do you have a dedicated test environment with hardware? And when you're rolling out a change, what approach do you take there?
So there's probably really two questions in there. Because one is around how do you test your NSO services that they're doing what you expect them to do, and there's another one around how do you what you really want to test is like that this config you're deployed to the network is a valid network configuration on doing that. I'm not going to answer that second one, though Marc might be able to address that with some of the work they do at ESnet. But internally, we have a virtual lab, mostly running
NetSense?
Yeah, no, these are actual XRD or like the virtual XR devices, stuff like that, in a lab. Mostly that's for our engineers to play around with, and it has NSO as part of it. But what we also do is we have an environment we call the NSO sandbox, which is we actually pull down the full NSO config from production NSO, and basically then we run that in. Marcus mentioned it, southbound locked, which it can't talk to devices, but it thinks it can talk. I mean, it can do all the internal configuration changes. So we can actually use that. I can bring that down, and I can basically load in any of my new NSO packages into that environment, and I can test them out to see if I run a redeploying a service, and I can see what changes. Did this thing actually work? The only thing that thing can't test is there are certain scenarios, like with route policy, like that'll look okay, but it will only fail when you actually push it to a device, because that device is finally going to validate it and say this is actually not valid config. So the virtual lab is sort of the last realm for that, and worst case, we figure it out in prod, and that does happen occasionally.
Yeah, we figure out a lot of stuff in prod. We do have a container lab set up running CRPDs, but for the purpose of testing clicks on the CRPDs have proven to be a bit too distant from the Juniper devices we are actually using. So for now, my lab is two real Juniper machines I can deploy stuff to, which is obviously much smaller than the real network. But that's the best setup we've got so far. That's the extent of our testing, along with the usual gamut of unit tests and smoke tests.
Yeah, we also it's kind of a multi-stage process, I think. So we started off with the robot tests, which are just kind of like running our services on NSO, and then we kind of cross-compare the configuration which falls out of it. That worked pretty well. It had some flaws because you're working against the device manufacturer Nets, which is a network element driver, which is part of NSO. It's kind of like it's the driver which is finally talking to the device. So we still there's still some bugs with that in terms of like things which slightly work different on devices or something like that. We also, and this is also just control plane stuff. So you can only validate, like, is the configuration you want to see. Then we use also Container Lab. We have an adaptation of that in a little project we call Rover, so where we can work with virtual devices and check like routing or something like that, so we can make sure that the configuration will actually lead to a working data plane. So there is something we are working on at the moment, is like basically getting real equipment in, so that we have a last stage where we can test against real devices.
Thanks.
We'll make an exception.
We're almost out of time, but last question.
All right. So what has been kind of the case that we have all, at least between us, kind of reinvented many wheels in this thing, and we are certifying those wheels against different network devices in our test environments. maybe we can work together and like have a certification lab and maybe some, services that we know are going to work with certain combinations of stuff and like that. And would this be a good, way to get this started?
Good one.
Yeah, that's a good concept. I'm not sure. I'm not that good of a network engineer. I don't know how mutable these things are, how much they change over time. But if you could actually build models that could just verify them, then that would be great. Love that.
All right. Well, thank you, everybody, for the good questions and the good conversations. And thank you to our panelists.